by providing more example. A 100 by 100 by 10 mm angle is to be welded to a gusset plate. The angle carries a load of 200 kN applied along its centroidal axis, which is 28.7 mm above the short leg, as shown in the figure. Use an 8 mm fillet weld with a minimum tensile strength. Fu is equal for 85 MPa. Fv is equal to 0.30 Fu. For letter A, determine the length of a transverse fillet weld along the edge of the angle in order to avoid eccentricity of the loading. So, yung transverse weld dyan, class, is ito, na perpendicular sa 200 kN. So, para maiwasan yung eccentricity, yung centroid ng 200 kN from the bottom is 28.7. So, kung magdadagdag tayo ng length sa taas, so dapat equal in length siya kung ano yung nasa bottom na length, which is 28.7. So, yung magiging length na ng transverse fillet weld natin is twice no 28.7. So, equal in length siya. So, 2 times 28.7. So, 57.4 mm. For letter B, pinapahanap, class, is the length of side fillet weld required at heel. Yung heel dyan is itong nasa baba. So, yung patalandaan dyan, kung nasan yung hanging part nung angle mo, di ba? Ito yung angle. Tapos ito yung hanging part. So, nandun yung heel. So, yan yung pinapahanap for letter B. So, to solve this one, kailangan muna natin hanapin yung strength ng fillet weld per linear mm. So, Q is equal to 0.707 times FWT. So, yung FW dyan is also equal to FB. No? So, given naman siya, which is this one. So, 0.707 times FB, 0.30 times FU, 485 times the thickness of fillet weld na 8 mm. So, yung magiging Q dyan is 0.30485 times 8. So, 822.948 Newton per mm. So, we're not done yet with our solution. So, let's store this value as A. Next, so assign na natin yung strength nung kada welds. So, yung transverse weld tsaka longitudinal. P1, P2, P3. So, yung kailangan natin is itong heel muna. Length nitong heel. So, to solve this one, so mag-take a moment tayo. Let's say ito yung side A, B. So, take a moment at A. So, take a moment at A equal 0. So, meron tayo ditong T2, which is the unknown. Times the moment arm na itong moment arm niya papunta dun sa side A, which is equal to 171.3 plus 28.7. So, 100. So, 100. What else? So, meron ka pang moment ng P3. So, wala pala tayo nung P3. So, pero makukuha natin yan kunin muna natin pala yung P3 equals to L tangensya. So, yung Q natin is A. Yung tangential natin is 57.4. Therefore, yung P3 is what? A equals. So, na-store na natin yung value ng Q. So, gamitin na lang natin yung stored value. So, therefore, yung P3 mo is 47237.215 Newton. So, naka-Newton na yan, class. So, store din natin to 37215 sa B para hindi na tayo paulit-ulit sa pagsusulat. Then, yung moment arm naman niya is 71, no? Ito yung P3, tapos ito yung moment arm niya. So, 71 siya. 0.3. What else? So, ito, may mga moment to. Then, ito din, yung 200 natin, minus 200 since opposite yung direction niya. Multiply na lang natin sa 3 para maging Newton times yung moment arm na 71.3 din, equal 0. So, ito, alam natin na B yan. Na-stored natin yung sa B. So, P2 lang yung unknown. So, X equals 100 plus 71.3 minus 200 times 1,000. 1.3. So, yung P2 mo is 108,919.866 Newton. So, let's store this value din. 66 sa C. Yan. So, makukuha na natin class yung length ng fillet weld na nasa heel. So, gamitin natin ulit yung Q is equal to P2 over yung length ng heel. So, yung Q natin is stored value natin siya sa A na 822.948 equals yung P2 natin na nasa C 108,919.866 over the unknown length ng fillet weld at heel. So, L2 is equal to so, yung P2 natin is nasa C. So, 132.353 mm. Ito yung sagot natin for letter B. Next, letter C. Determine the length of side fillet weld required at toe. So, ngayon, yung kailangan naman is yung toe. Yung fillet weld na nasa toe. Ito. So, to solve this one, kailangan din hanapin yung P1. So, mag-summation forces na lang tayo horizontal equal to 0. So, yung meron tayo ditong P1 which is unknown plus yung mga same direction to kaya mga positive siya plus P3 plus P2 minus 200 kilonewton yung tensile load natin times 10 raised to 3 para maging newton. So, yung P1 natin is unknown plus yung P3 na na-stored natin sa B plus yung P2 na nasa C minus 200 times 3 equal 0. So, yung P1 mo is 438 842.919. Then to solve for the L1 ng P1, so L1 is equal to 43,842.919 over Q na 822.948. So, galing to sa Q equals P1 L1. So, therefore, yung L1 natin is 842.919 over 53.275 mm. Next problem is this one. So, sabi dito, a channel is used as a tension member with the web of the channel welded to a 9.5 mm thick gasket plate as shown in the figure. The tension member is subjected to the following axial loads. Use LRFD. Service dead load equals 180 kN. Service live load is 250 kN. Wind load is 276 kN. For channel, FY is equal to 345 MPa. For gasket plate, Fy is equal to 248 MPa. Fu is equal to 400 MPa. Size of E70 electrodes is equal to 4 mm. Ultimate tensile strength of E70 electrodes is equal to 480. Fw is equal to 0.6480. So, solve the letter A. So, determine the design factor tensile force. So, sa introduction natin ng mga design philosophies, so, dinigay ko sa inyo yung mga load combinations. So, dito sa example natin, tatlo yung service loads na meron yung problem, which are the dead load, live load, and wind load. So, pipili tayo dito ng load combinations. So, yung isa, yung combination 1, 2, at saka 4. And then, i-compare natin kung sino yung may mataas na value ng factored tensile force. So, yung isa, yung PU is equal to 1.2 dead load plus 1.6 live load. So, yung combination na yan is nasa 2. So, solve natin. Yung dead load dito is 180 plus 1.6 times 250. So, wala naman na roof live load, wala din snow or rain. So, neglect na lang yan. So, sa computation dyan is 180 plus 1.6 times 250. So, 616 kilonewton to. Gamit yung combination 2. So, isa pang combination is yung 3. Pero take note, meron kang makikita na 1.6 roof live load, snow or rain. So, ito, maneneglect natin to sa computation. Yung kailangan is yung 1.2 at saka itong L or 0.5 na wind load. So, may nakalagay dyan na L or 0.5. So, pipiliin nyo dyan sa dalawa yung makakapagbigay ng larger value. So, yung live load dito is 250. Then, yung 0.5 naman daw na wind load. So, computein natin. So, merong given na 276. Therefore, 250 plus 250 ito sa live load, kilonewton. So, kailangan lang is yung sa wind load. So, 138. So, yung mag-govern dito between this L or 0.5 W is yung live load na 250. So, yung PU dyan is equal to 1.2 D plus, wala naman kasi tayong 1.6 na roof live load. So, neglect nyo na lang yan. So, live load lang na 250. Okay. Based dito sa computation natin sa gilid. So, yung dead load natin is 180. So, substitute natin. So, calculating it, 1.2 times 180 plus 250. So, meron kang 466 kilonewton. So, sa dalawa pa lang, makikita mo mas malaki pa rin yung isang combination, combination 2. Then, may isa pa tayong kailangan i-check yung combination ng 4. So, yung 1.2 times dead load plus 1.0 wind load plus live load. So, yung ibang loads dito, so, ine-neglect na lang natin to. Hindi na to kailangan kasi wala naman binigay. So, to solve this one, just substitute the values. 1.2 times dead load is 180. Yung wind load is 276. Plus, yung live load is, ano yung live load? 250. So, computing this one, 1.2 times 180 plus 276 plus 250. So, meron kang 742 kilonewton. So, sa tatlong combination, ito yung mag-govern kasi siya yung largest na factored load. For letter B, determine the length of the longitudinal weld. Longitudinal welds L. So, to solve this one, ano yung kailangan natin gawin? So, kunin muna natin class yung kailangan, di ba? Yung length ng longitudinal welds. So, to solve this one, isolve muna natin yung Q. Is equal to P over L. No? So, pinapahanap is the longitudinal welds. So, okay. So, makukuha natin yung Q. Another formula is 0.707 times T times FW. So, given yung thickness ng fillet weld, given ba? Yung thickness ng fillet weld. So, nandito. So, 4 mm times the FW na 0.6 times FU, 480. So, yung Q mo is 0.707 times 4 times 0.6 times 480. So, therefore, yung Q mo is equal to 814.464 Newton per mm. Yeah. Next is, gamitin natin yung formula nung design shear strength ng fillet welds, no? na P is equal to 0.85 times the P is equal to 0.85 times Q times the longitudinal length plus 1.5 times Q times the transverse weld. So, yung gagamitin natin dyan, class, na P is yung na-solve natin na 742 kilonewton. Kasi yan yung factored tensile force natin. So, take note na we will use design philosophy na LRFD. So, kailangan natin to i-multiply din sa 0.75. No? So, to solve this one, P is equal to 742. Multiply mo sa 3 para maging Newton. 0.85. Yung Q mo is, so let's say, i-store natin sa A na lang. Yung Q mo is nasa A. Times yung unknown longitudinal welds. So, yung longitudinal welds dyan is yung total. So, i-divide pa natin to sa 2. No? Pag nakuha natin yung unknown. Plus 1.5 times Q times yung transverse length na equal to 250. Ito yung transverse. 250. Multiply mo sa 0.75. So, yung length ng, ito yung total length ng longitudinal weld. So, 742 times 3 equals 0.75. So, 0.75 yan po yung reduction factor based sa LRFD. 0.85 times yung Q. So, na-stored natin yan sa A times the unknown total longitudinal weld plus 1.5 Q times 250. So, therefore, yung total longitudinal welds is 987.888. So, para makuha mo yung longitudinal weld ng each side, no? So, divide natin siya sa 2 since pareho yung length nila. Same lang yung length. So, divide mo sa 2. So, 987.888 divide 2. So, yung sagot natin is 493.944 mm. Total. Letter C. So, for letter C, determine the block shear strength of the gusset plate. So, ngayon, yung kailangan daw is yung block shear ng gusset plate. Ito yung gusset plate. So, given din naman yung properties ng gusset plate, ito po. Yan. Wait. Sabihin ko na lang siguro yung kulay. Ito yung gusset plate. So, block shear yung kailangan. Yan. So, to solve this one, so, kailangan muna natin kunin yung mga area net ng shear at saka ng area net ng tensile. So, sa area net ng shear, ito po yun, itong dalawa. Kasi nga, subject siya sa shear due to the tensile load na horizontal. So, parallel siya dun sa tensile load. Then, ito naman yung area net ng tensile na tensile na perpendicular dito sa load T. So, to solve this one, so inahin natin hanapin yung area net. V is equal to ano yung magiging area. So, alam na natin yung length, no? So, nakuha na natin equals to 493.944 or gawin na lang natin na 400, i-whole number natin, 494 mm. No? Yung galing dito. So, let's say 494 mm. So, yung area net mo is 494 times yung thickness. Ano yung gagamitin mong thickness? Siyempre, yung thickness nung sa gusset plate. So, given dito yung thickness ng gusset plate na 9.5 times 9.5. So, yung area shear, yung area net ng shear is 2 at twice kasi dalawa. So, isa, dalawa. So, computing this one, 494 times 9.5 times 2. So, magiging 9386 mm squared. Then, area net ng tensile. So, meron tayong dimension na 250 times the thickness. So, 250 times the thickness na 9.5. So, 2,375 mm squared. Yan. So, to solve the block shear, di ba yung gamit na formula is equal to VRN is equal to 0.6 FU times ANV plus FU times ANT. So, minumultiply natin siya sa sa reduction factor of 0.75 for LRFT. So, substituting the values, yung FU ng design ng gusset plate is 400. So, ito yung FU. 400 times ANV, 9386, plus FU, 400 times ANT, 2375. Multiplying it by 0.75. Therefore, yung makukuha natin is 400 times 9386 plus 400 times 2375 times 0.75. So, 2,401.98 kilonewton. Pero kailangan pa natin to i-compare sa upper limit, no? Yung upper limit natin na Rn max is equal to, ano yung formula natin? To 0.6 Fy times times Ag times Ag ng shear plus FU ng ANT. Then multiplying it by the reduction factor. So equal to 0.6 Fy is, ano yung Fy? 248 times AGV o yung area gross ng shear. So same lang din no yung gagamitin kasi wala naman kasing butas. So ito lang din yung gagamitin mo na area gross ng shear. So 9,386 plus FU na 400 times ANT na 2,375. Times 0.75. So 0.6 times 248 times 9,386 plus 400 times 2,375 times 0.75. So yung sagot is 1,759.977 kilonewton. So sumobra ito sa upper limit. Therefore, yung mag-govern is yung upper limit. So again, ulitin ko lang, yung area gross ng shear is equal sa area net ng shear. Since wala ditong butas, so mag-i-equate lang sila. Kaya yung ginamit natin sa area gross na V is 9,386 pa din. So that ends our part 3 nitong problem solving.